Yesterday, all of the inequalities that we solved were in factored form already. What do you notice about this? Yeah, it's not in factored form, so we have to factor it first. Have to. There's no other way of doing this. So if you want to go ahead and get started, you're hunting for a for the first factor, right? Plugging things in and trying. Why are we doing this? Because the method that we use to solve these inequalities is by drawing a sketch and seeing where the function that's on the left side of this inequality there, seeing where it is greater than 0 and less than 0. And we're using a sketch for that. So we have to find the x-intercepts because that's where it's going to change from being above the x-axis to below the x-axis. We'll be at an intercept for these kinds of functions. And so we have to find the x-intercepts, and we do that by factoring. Sometimes what I do, with this one it's a little bit harder. I think the next question is a bit more obvious. Sometimes what I do is I just look at the coefficients and I look to see if any combination of them gives me 0. And I'm not worried about signs. 7 and 2 is 9, and 2 and 1 and 6 is 9. So like if one of those was negative and one of those was positive, that would give me 0. So right away I'm starting to think, I wonder if either positive 1 or negative 1 would work. Because if you can't do that with the coefficients, 1 and negative 1 won't work, and you don't have to waste time trying those, right? And some of this is about getting good enough at it that you just don't spend a ton of time looking for factors. There wouldn't be too many possibilities in this one anyway, because it could only be plus or minus 1 or plus or minus 2 that would work. So I believe x minus 1 works out as a factor. Did anybody else get that?
I have a question.
Sure.
Couldn't it also be like 1 over 2?
Yes. But we don't usually look for those. And so I think we talked about this the other day, just in case somebody goes to university next year and their university professor gives them questions where you have to look for those as well. So I was trying to sort of warn you that there are other questions out there that are factorable that might not have integer factors. But I'm not going to give you questions like that. You'll never have to do that. But as you know, you could. Yeah. But you could. For me, it's always good enough to just check the factors of the constant, and you'll be able to find enough factors like that to get it down to a quadratic, and then a quadratic can be factored other ways. We don't have to use factor theorem, and we shouldn't use factor theorem for a quadratic because there's faster ways. Don't forget the greater than 0 part at the end every time. And then this little trick happens where I get x minus 1 again. I got it twice. In this case, if you didn't try that, you would find another one, but sometimes you wouldn't. So you got to make sure that you check the same one again, because it could be a factor twice.
Are we supposed to factor that with one or with
synthetic?
Yeah.
Probably is how you're going to do it, yeah. And that last quadratic, so I'm going to write this like this, and this is going to be pretty important, right? On the test, some people didn't. They left it, all the separate brackets written out, and that would be fine. You wouldn't lose a mark for that, don't worry. But when you're graphing, you want to know that the type of x-intercept you're looking at. And it would be, you would have a hard time if you didn't do this and you tried to draw a degree 4 polynomial. Like I think something wouldn't work and you get yourself confused. But you want to do this from the beginning. Notice that that's important. because a turning point x-intercept is very different from a pass-through. It's going to give you different outcomes. It's going to be totally different. So I have -2 and then positive 1/2 and positive 1. And positive 1 is a turning point x-intercept. What else do you notice about this? What else is important about this, Adam? Yeah. Yeah, very good. You need to be careful of that symbol. Absolutely. That's going to play a role in this question for sure. So you got to look at that. Before, I haven't even drawn my graph yet. Before that, positive leading coefficient, and I already said this, but degree 4. So all those details that we need in order to determine the end behavior. And if anybody is still stuck on end behavior, it doesn't go away. You've got to get that figured out. Okay. And so again, you might now better understand on when we did this sketching in the last unit, how we're using that to solve these questions. And if you didn't understand end behavior, you wouldn't be able to sketch these properly. You wouldn't be able to solve it. But this should go like this. Whoa. And then it's going to, I think it's at that one, right? That's a turning point. Yes. So there we go. And then after I've got my sketch done, all of that work was just so I could sketch. And then I read my solution from the sketch. And some people I know have a hard time with this, and so this is what you need to do enough practice so that it makes sense. Where is this function greater than 0? In other words, where is it above the x-axis? And I can kind of trace out where it is. In those 3 places is where it's above, and we're not including equal to. And then how do I write that? Well, this is an interval of all numbers that are, all values of x that are less than -2. Will -3 work? Yes. If I'm use the number -3, I'm going to be over here somewhere, and my value is going to be up here, which is greater than 0. What about -4? Still. What about -5? Still. What about -1? No, -1 is going to be there somewhere, and I'm below. So how do you write that? People get confused when we do this. Therefore, x less than -2. And you say, but it's bigger. Because look, the line's above the -2. I don't know if that's what people are thinking, like it's literally the line is above the -2, but your brain sometimes plays these tricks. But I'm wondering about the x values. And the x values in this section of the graph are all less than -2. So that's how we write it. Then I also have between, this little part here is between 1/2 and 1. And folks, again, you cannot write these wrong. So when I check your learning goal today, and I think we do one tomorrow, and you get that feedback, you got to make sure that you're writing these correctly with the signs pointing the right direction. And we always start with the smaller number. So 1/2 less than x less than 1. And then x greater than 1. Can anybody explain why you have to write though that as 2 separate ones? It's at when it's equal to 0, and that in this question is saying greater than, not greater than or equal to. If it said greater than or equal to, my solution set here would be written differently. We're going to see that in the next example, I believe. Isaac. Okay. Everybody good? Let's try another one. What do you notice about this one? Yeah, it's one of those ones that can play a trick on you. Looks like it's factored already for us, but greater than -25 isn't going to work. Now hold on. I want to show you something. Put your pencil down and watch. Don't write this down. What if I did this? So this is degree 3, looks like it has a positive leading coefficient, which means it's going to do this. Something like this. I don't know for sure what it's going to look like. Oh, actually, I kind of do. Was that good enough? I'll draw it a little bit better. So -4, -1/4, and +2. Okay, so it's going to go. So what if we do that? And what if then I graph -25, and I say, when is this function greater than or equal to -25? Does that make sense? Would that work?
You can find one place, you can find like far left side that it goes off into one direction. It's always going to be
Why could I find that one?
because you know the end behavior. You could,
Okay, interesting. Oh, I see what you're saying, I think.
How would you know exactly like how would you know that y would be exactly there? Like if it was there? Like I just didn't know if it would be like lower than the actual food.
Nah, very good. Yeah, good thinking. Isaac? Yeah. So, like, this makes sense conceptually. The graph of this makes sense. When is that function, which is just this side, greater than -25? The problem is, which is what you guys are getting at, I can't find those points. We cannot determine those points. Well, actually, we can determine them, but it's by expanding and simplifying, moving everything to one side, and then refactoring, and like the way thing what we're going to do anyway. That's the only way to find those points. So conceptually, this does make sense. Like you could think of this as, when is this function greater than -25? Now, when we expand, simplify, move everything to one side and refactor, we're going to have a different expression. And we're going to be then asking, when is that graph greater than or equal to 0, I believe, right? So it'll be a different function, but it's the same concept. So this conceptually makes sense, but it's just not useful to us in this case. If I had graphing software, I could do it with software and ask the software to find those points for me. That would work. Okay, so go ahead and try that. I want you to practice your expanding skills. You can so remember what I said about the learning goal, that you want to make sure you get that right. So before you go any further, you can check your results against mine and make sure that you expanded properly. And again, like I was saying before, you can see that 4 and 9 is 13 plus 17 is 30. So I've got 30 from 3 of the terms and 30 from one of the terms. So it kind of looks to me like one will work and cancel those out. And indeed it does. X minus 1 is a factor. Okay, let's divide that out. All right, what do you think we should do next? Nice, good catch. They're not side by side. Sometimes that's enough to make us miss that, but that one's squared. And then sketch it, right? Yep. In this case, I only have two, so I might not need to worry too much about this. And one of them is negative and one of them is positive. But this is negative 17 over 4, which is negative 4.25. Obviously, if you have a strange fraction that's not obvious, like a half or 3/2 or 2/3 or something, if you put it in the wrong place of your graph, like this is between negative 4 and negative 5, but if I put it on the wrong side of negative 4, if I had a negative 4 here, because I didn't check the decimal or something like that, then your graph, your answer would be wrong, right? Obviously, if you sketch it wrong, your answer is going to be wrong. So just a small little, I guess, warning, be careful of strange fractions like this. You probably want the decimal version because that's the one that we can use better to sketch. So this is degree 3, and it's a positive leading coefficient again. So I'm going to go, but I have a turning point. So I go like this, and then turn, whoops, I'm going to try that again. Now we read our solution from the graph. When is this function that I've sketched greater than or equal to 0? And if you don't have your sketch done, I want you to look up at mine. Make sure yours is the same if you have sketched it. But I want everybody thinking about this. What is our solution going to look like? Adam, what do you think?
Where x is greater than negative 17 over 4. Or greater or equal to.
Good. Anything else? Sabia, what do you think? You agree or disagree?
So I think the way I wrote it is I chose to write it from negative 17 over 4 to 1 and
Yeah.
greater than 1.
Right, so written as 2. So hold on. X greater than, wait, no, you would have done this, right? Negative 17 over 4 less than or equal to x less than or equal to 1. And then also included x greater than or equal to 1. What about at 1? Because it's when it's greater than or equal to 0. It's equal to 0 at 1, right? So what would I have to add to this when x equals 1? Hold on. All of this means the same thing as this, but we want to write it with as fewest steps as possible. So this is the solution that I want to see. This means the same thing because I've got this part is all of this, and this part is this, and it includes 1 because it's greater than or equal to 0, and it's equals 0 at that point. So I do want to include it. But why would I write all 3 of these when I could say it the same way like that? So that's what I want you to do. So even if you think of it this way and write it out, then scratch it out and rewrite it in the fewest number of intervals as you can.
Also, for the second version, like, why would you add x equals 1? Because don't you already include that?
Oh, yeah, you're right, because I have the less than or equal to signs. What if I did it like this? And it's weird to kind of say it both times. Like, why? Like, I'm saying it both times, but then why am I breaking it, right? Yeah. So what if I wrote it like this? Then I would have to include the equals 1 thing, I guess. But regardless, the other way is the way that we would actually say it. Notice how this is different. Like, and if you don't fully understand this, make sure you've got it copied down or look at it online or something and look at how it's different from this one because they look similar. Why did we have to write this one out as 3 parts? But this one, we could write it only as 1. If you don't understand that, you need to do some thinking and make sure you figure that out. And there's at least one other case where the solution looks different that we haven't done, but it's in the homework. So if you have not been doing the homework and you haven't seen that case and then it pops up on a learning goal or a quiz or something like that, which I think you'd be inclined to expect it will, you might not know what to do. And so if you're not sure, you can come and ask me about it. Like, or if you get a question, you don't know why the answer looks like this when you're looking at the solutions, ask me about it. But I think I know there's at least one more case, and it's not in our next example that we're going to do right here. And I don't like it probably won't come up for us in class. So be aware of that.
So in all cases, would you want us to write the shortest way?
Absolutely. We always do as a standard. Yeah.
Also, when we're doing the synthetic division, if we label it as f of x, is that okay? Like
Yes. I would even be inclined to think that you're going to do all of that off to the side. Like I would try not to do it in here. I would try to do it off the side or on scrap paper, and I don't even need to see it. So you're really doing it for yourself. So you could kind of do whatever you want, I guess. This is the solution that I want to see, and I would prefer to see it line by line by line instead of synthetic division right in there.
So we don't have to do synthetic.
But you don't have to. How else would you do it? Oh. Tricky, tricky, tricky. What do you think about this one? Very good. Collect everything to one side. Okay, so give it a try. This is our last example for today. Well, actually, maybe I'm lying. We'll see if there's one more, but it's different. We'll see if we get to it.
Yeah.
You would have something that's not factorable.
Yeah.
So I couldn't give you a question like that.
I think there was one that was like f of x just equals 2. And does that still have x? So it's interesting like when y is 2, not when.
If you can, don't just copy my solution. In fact, I don't want you to copy my solution, but hopefully, I would guess most of you got this. So I did it a bit of a different way on purpose, just so you know. So don't worry about that. But when you collect like terms, you should probably have something that looks like that. Your signs should be that way as well. And those should be the numbers. And then you can factor it. I will tell you why I did it this way when you're done. If you can, I want you to solve it all the way on your own first. Yes. Oh, did I? Yes, thank you. Of course. On both those parts, right? I did it twice. Okay, if you're not all the way caught up, that's okay. Put your pens down and watch, because I'm going to show you something, and I want you to be paying attention because it might be a little bit confusing. So there's my graph. If some of you graphed it already, and yours probably looks different because I had a negative leading coefficient. Right? What I couldn't do is get rid of the negative. But if I do that, what do I have to do? Thank you. We got to flip the sign. We talked about that yesterday. And the graph of this will look like this. So regardless of which graph I use, because this one is when is it less than 0, and this one is when is it greater than 0. So because they're mirror images, it will be the same solutions. Does that make sense? And two things about it. The negative out front might be more confusing. I don't think most of you would have done that. I hope most people would have planned ahead and moved everything to that side. It would have been the easier way to do it. Is that how most people did it? Like that's what would make more sense. And you'd be surprised how confusing it is that the zero's on the wrong side. Like, because we're so, again, we do things the same way for a reason, because it makes our lives easier. But the disadvantage is if all of a sudden it's wrong, it's harder to do. So you'd be surprised unless you've done it a few times or unless you're really good at this stuff, that having the zero on the wrong side is tricky. And if I move the zero to the other side, I got to make sure I do the sign the right way, because it's not just an equal sign that you can turn it around, right? So you'd have to write it the correct way. So just be mindful that you got to be pay attention to negative leading coefficients and which side the zero's on and which way the sign is pointing, those kinds of little things. And I believe that the solution in this case, so when is the blue one less than 0, because 0 is greater than or equal to it, will be from -2 less than or equal to x less than or equal to +3/2. And when is it less than 0? When x is greater than or equal to 3.